Our story begins with a bang. About 13.8 billion years ago, the universe exploded into existence. This event, the Big Bang, marked the birth of space and time. In those first moments, the universe was incredibly hot and dense. As it expanded and cooled, particles combined to form hydrogen and helium. For millions of years, the universe was dark and quiet. But gravity pulled hydrogen and helium together, forming massive clouds. These clouds collapsed under their own weight, triggering nuclear fusion. The first stars were born, forging heavier elements in their cores. When they died in supernovae, they scattered these elements across space. Carbon, oxygen, iron, and all the building blocks of planets were born in these stellar furnaces. This cosmic dust would eventually give rise to our solar system and Earth itself. About 4.6 billion years ago, a giant cloud of gas and dust began to collapse. This cloud, rich with elements from long-dead stars, would become our solar system. At its center, gravity compressed material so tightly that nuclear fusion began and our sun was born. The leftover material formed a flat disk called the protoplanetary disk. Tiny particles of dust and ice collided and stuck together, a process called accretion. Over millions of years, these clumps grew larger, becoming planetesimals. The largest planetesimals attracted more material, clearing their orbits of smaller objects. These became the planets we know today. Earth formed through this process of accretion, starting as just another clump in the protoplanetary disk. It was in the right place, not too close to the sun and not too far. It gathered rocky material and some ice, growing into the planet we call home. As Earth grew, it became very hot. Energy from collisions and radioactive decay caused this heat. The young Earth was a ball of molten rock. Differentiation began. Heavier elements sank, lighter elements rose. This created Earth's structure: core, mantle, and crust. The core separated into a solid inner core and a liquid outer core. The liquid outer core generates Earth's magnetic field. Above the core, the mantle formed. The crust formed as the surface cooled. As Earth continued to cool, its surface began to solidify. Volcanoes spewed out gases from Earth's interior, including water vapor, carbon dioxide, and nitrogen. As the planet cooled further, the water vapor condensed and fell as rain, creating the first oceans. The early atmosphere was rich in carbon dioxide and nitrogen, with no oxygen. This greenhouse atmosphere kept Earth warm, preventing the oceans from freezing solid. The constant rain and the action of the first oceans began to weather the rocks, releasing minerals into the water. The early oceans became a rich soup of chemicals, crucial for the next chapter in Earth's story. By about 4 billion years ago, Earth had cooled enough to have a solid crust, oceans, and an atmosphere. The Moon's gravitational pull created enormous tides in Earth's oceans. Meteorites and comets continued to bombard the planet, bringing more water and organic compounds. In the periods between impacts, the Earth's surface could have been quite habitable. The early oceans were likely rich in dissolved minerals and organic compounds. Hydrothermal vents on the ocean floor spewed out hot, mineral-rich water, creating local environments that were protected from the harsh conditions on the surface. These vents might have been perfect incubators for early life. On land, the first continents were beginning to form, and plate tectonics had already started, creating diverse environments where life could potentially thrive. Around 3.8 billion years ago, life began. Complex chemicals in Earth's primordial soup formed the first self-replicating molecules. These simple molecules could make copies of themselves. Over time, they developed membranes and harnessed energy. Fossils show the first true cells appeared about 3.5 billion years ago. Some evolved photosynthesis, producing oxygen. Oxygen built up in the atmosphere. This paved the way for complex life, including us.